Welcome to this video lecture on the subject transmission lines and antennas. So in this lecture we are going to discuss about Smith chart and its applications. So first of all, what is the need for the Smith chart? So we are going to find the parameters of a transmission line. So what are the disadvantages of numerical calculations? So we can use the calculations, but it is difficult to use all the formulas and do calculation, and it takes lots of time to compute the transmission line parameters. So we can use the tool. It must be easy to use without tedious calculation and also less time consuming. So first we can see the Cartesian circle diagram in this picture. So the range of impedance or admittance values are limited, and interpolation of constant S circles and constant beta S circles on the chart is difficult and inaccurate. So this is the disadvantage of Cartesian circle diagram. And now the Smith chart, which is the transmission line calculator, it overcomes the drawbacks of Cartesian circle diagram. It is developed by P. H. Smith in 1939, and it is a graphical tool for use with transmission line circuits and microwave circuit elements. So in this diagram we can see the constant resistance circles. So this is one component of the Smith chart, and these are the constant reactance circles, where the upper part is the inductive reactive component and lower part is the capacitive reactive component, and reactance axis is given in the circle. So this is the Smith chart comprising both the resistance circles and reactance circles, and this is the overall Smith chart where the real impedance axis and imaginary impedance circles are given. So in this, the center of this chart is the 1 plus J0, and distance along the transmission line, it is wavelength is taken along the outer circle, and the angle of reflection coefficient is given in degrees, and the inductive reaction and capacitive reactance are measured from the reactance circles. So this is the overall Smith chart diagram. The Smith chart, below the Smith chart we have a scale that is used for finding the magnitude of reflection coefficient. So this is an activity. So the properties of the Smith chart. So it can be used as an impedance chart or admittance chart. So in the impedance, all the impedance values are normalized. So that is Z by R naught. So real axis or horizontal axis represents the resistance or real part of the impedance. Imaginary circles represents the reactance. The upper half imaginary circles are inductive reactance and lower half are the capacitive reactance. So there are three concentric external circles. The innermost circle is the graduations of inductive and capacitive reactance, and second circle is the angle of reflection coefficient given in degrees, and third circle is the distance along the transmission line is given in wavelength. The total length of the chart is 0.5 lambda. In the clockwise motion we get wavelength towards generator, and in anti-clockwise motion we get wavelength towards the load, and V max is the right side of the chart and V minimum is the left side of the chart. So it is right side is the open circuit condition or infinite impedance, and left side is the short circuit condition or zero impedance. And applications of Smith chart are, it is used to find the magnitude of reflection coefficient and angle of reflection coefficient and voltage standing wave ratio, unknown load impedance and admittance, unknown input impedance and admittance, and Vmax and minimum, and also it is used for stub matching. So we can see an example problem here. So this is used to solve the reflection coefficient standing wave ratio using Smith chart. So the given values are length 20 meters and Z0 characteristic impedance is 50 ohms and frequency is 2 megahertz. So it is solved using the normalized, first calculate the normalized impedance ZL by Z0, and we have to locate this point P on the Smith chart. So the point P is mentioned in this diagram. So from this we can calculate the standing wave ratio from the Smith chart by drawing the S circle with the center of the chart and radius equal to the distance between O and P. So after drawing this circle, we can see the Smith chart here, and angle of reflection coefficient is given the point at which the line cuts the outer rim, that is second concentric circle. It gives the angle of K. And magnitude of reflection K, it is calculated from the scale given in the Smith chart. So the scale is shown here. K value is 0.34. So like this we can calculate the input impedance. So these are the other examples of Smith chart. So these are the assessment question. The Smith chart is a graphical technique used in scenario of transmission lines. State true or false. And the second question, the Smith chart consists of the constant R and variable X circles, and variable R and constant X circles, constant R and constant X circles, and variable R and variable X circles. The circles of the Smith chart pass through which point? Next question is, moving towards the clockwise direction in the Smith chart implies. So these are the references. Thank you for listening this lecture.